Okay, that's what I want. Sorry. All right, so I think I'm recording on this computer. Right. It's okay if I don't give you a long introduction?
No, no.
Okay. I thought maybe we should get his bio.
That's okay.
He's
He speaks less than you.
Oh, he does. Okay.
The thing about Hong Kong is you get so much help. You know, everyone is helping you.
Really? Oh, that's nice.
It's a paradise.
Wow, that's in Hong Kong?
Yeah, they have tremendous amount of staff.
Wow.
Yeah.
Okay.
One man for computers, one woman for something, and somebody else for something. So a spot.
All right, so I'm not muted. All right. All right, so I guess I'm going to get spoiled then, maybe.
They're spotted. Yeah.
Okay, I just want to, all right, I'm going to send out a, all right, everyone out there remotely, could just somebody let me know in the chat if you could hear okay?
Nobody.
And then also let me know if you could see the slides. I don't have them in, presentation mode, but just let me know if you could see, my desktop and the slides there. I'm wiggling them around.
Yeah.
Oh, okay, I heard. Yes, you can hear. Okay, Rosalind, can you see the slides too?
We see them, but they're not full screen, Wendy.
Okay, good. All right. I'm going to go full screen now, and then we'll have Noser start. And thank you. And just everybody make sure you mute once we get started. All right. So Noser, you could just, hit the arrow keys.
Okay, so this is PowerPoint.
Yeah. But wow, this looked funny here. Wonder why it didn't. Views. Oh, okay, that's what you want. Oh, he's did it fancy. No wonder. Okay, you had stuff coming in like this. Oops, I want to do that.
Oh, I see. Yes,
Yeah, and I think you can just use the right arrow key.
Okay.
Or the left arrow key. Okay, so those are the two keys right there.
Right and left. Okay.
Yes. All right. I'll let you sit right here.
All right. Thank you.
Thank you.
All right.
And hopefully people could still hear me on the phone. But yes, if you project that way, that's perfect. So it's my pleasure to have Noser Singh Purwalla here giving us a talk today on the history of probability. And I've known Noser for
Long time.
a long time. I first met him when I was at the Office of Naval Research, and I had the honor and privilege of giving him some money to do fantastic work. So he's here to not talk about that, I guess, but to teach us about probability. And he's somebody who's very knowledgeable about it. So this is going to be very interesting.
Thank you, Wendy.
Take it away, Noser.
Yeah, thanks for having me, and thanks for everyone to come. This is the first time I'm giving this talk, and it's unusual in the sense that it doesn't have any mathematics or anything, but it just has a history of how it all came about and where it is right now. So let's see. So this is the title, and some publishers are interested in publishing this work as a little book. So this is also a little bit of a dry run for what I think I can do. So feel free to interrupt. I'm in no hurry to go back, and I'm not hungry either.
Okay.
So, okay, I've just put my name here. So let me give an overview. So here is a top-down historical perspective on the several phases in the evolution of probability, from its origins for imperial needs to its current state as a branch of mathematics. Nothing is original. It's all been bootstrapped and put together. I don't claim credit for anything. Occasionally, I have an interpretation, which maybe was either inspired or it was just pulled out of my memory, having read it somewhere. So probability is considered as a part of mathematics, though some mathematicians may not agree, but it evolved in 5 stages. There was a period of stagnation when the mathematicians felt that probability was really not a part of mathematics, and doubts were raised about its relevance as a mathematical science. I claim that neither probability nor statistics are a part of science. They are a part of mathematics, all right, but they may not be a part of science, and the French, when I once said this, revolted, saying that mathematics is science. Okay, there are some paradoxes in probability. They came about because of a lack of precise definition, and that opened its last phase. So let's talk about the prehistoric phase. And most of the books on history of probability are written by Westerners. So there are certain things that emphasize Western contributions more than others. So the rulers of ancient Egypt, I wouldn't call them Westerners, but those of Egypt, Greece, and Rome collected census data for taxes, grain distribution, and administration, and these impacted its origins. I think they still collect data for taxes, and that's why I don't go to the census department. But my ancestry is Iranian, Persian. They're good Persians. And from what I understand is they collected data also for irrigation, taxes, and postal purposes, but I've never seen that mentioned. The English, of course, the Doomsday list of William the Norman, Conqueror, was an exhausted economic survey.
No, sir.
Yeah.
Sorry. I'll get close to the mic. Do you know why they call it the Doomsday Book?
No, but that's a good question. I'll find out.
Okay.
But Josh may know it. It's famous, called the Doomsday Book. Yeah, but we should find out. Any comments? I appreciate, because I'm going to write all this up. This is well known. In London's Bills of Mortality were published since 1517. And the word chance of death in a given time period, chance of survival, originated in 1535, almost a century before the celebrated table by Grant. The word chance now, for somebody who looks into the roots and foundations of probability, the word chance has a different interpretation than probability. The two are slightly differently interpreted, even though they're interchangeably used. But of course, there was also maritime activities when the Europeans started going all over. And it came from insurance, and also from the Renaissance, when experimentation in the natural sciences, errors of observation and all, took root into one's thinking. So these are some of the prehistoric origins. They came about because of a need. There's also the philosophical angle. And from a philosophical angle, interrelations between chance and causality have been on the philosopher's agenda since ancient times. Right now, I see a lot of statisticians involved in causality. a lot of computer scientists involved in causality. I still have a little trouble with what's going on, but the fact remains that philosophers definitely did contribute and continue to contribute in this particular arena. There is ancient Indian religion, and they had a book. It's written out in red. I can't pronounce it myself, so I won't say it. And there is some mention of probability in that particular document. Then, of course, there is the famous philosopher Thomas Hobbes, who may have started a lot of what we do in statistics, whose thesis was that no matter how long we observe a phenomenon, this is not sufficient ground for its absolute and definite knowledge. Particularly of interest to computer scientists. You can test and test and test a piece of software, and it works. It doesn't mean that it'll work again. And I have written something on this, and it's written something which essentially says that this is a topic of great interest. A lot of physicists and all have written on it. But anyway, Thomas Hobbes raised this particular point. So to summarize, in the prehistoric period, it was census, commerce, Renaissance, and philosophy that contributed to the origins of probability. Now let's go and ask the following question.
I was just going to ask that.
Yeah, I'm glad you did, because you'd be surprised at the answer. Was probability not spawned by gambling? What do the historians have to say about it? Well, this is the debate. The historians claim that since gambling was practiced since 5000 BC, it could not have taken 6,000 years for it to influence probability. So essentially, they question whether gambling was the source of probability, but we'll get to that more as we move along. That particular view was that it was commerce which influenced the development of probability. Commerce and industry influenced the development of probability, not necessarily gambling, and we'll see why. But gambling has an impact on probability, and its earliest traces are in the literature under this title by Richard Fournival and Dante's Divine Comedy, wherein combinatorial arguments pertaining to games of chance were mentioned. So there is some indication of gambling as having an impact on probability. But here is the most interesting issue. In Italy, Pacioli published Summa de Arithmetica Geometria Proportion, encyclopedia of the mathematical knowledge of his period in Venice, and there he questions the fair division of stakes when a match is stopped in advance of agreed termination of the game. So two people agree to gambling, they agree on certain rules, and in the middle of the game, one of them says, I have to leave, so the game is still not over. What should be the proportion of stakes? And that's called the problem of points. And Pacioli offered a solution which entailed notions of probability. And the Pascal-Fermat correspondence was the trigger point for this piece of work. So this is titled The Earliest Writings on Probability. Very, very noteworthy is, and everyone now knows this, or at least everyone recognizes, it was the book by Cardano. And you'll be surprised what he did. He made a fundamental contribution in 1501, 1526 in this particular book. And he basically laid out all the rules as we know it. he enumerates possibilities, permutations, deviations of frequency proportion, introduces the notion of a fair game, an expectation, equally likely events, uses the addition and multiplication rule of probability for independent events. Basically, the key bread and butter tools that we have were essentially enunciated by Cardano in this particular time. So even though gambling didn't influence probability, gambling created the mechanism and the rules for probability. He even came close to inventing the law of large numbers, and Cardano was indeed, and he only focused on games of chance. He was not interested in other things. He was only interested in gambling, which means games of chance. But he had it all settled down. Following Cardano came Tartaglia. He published in 1556 his treatise on number and measures, in which he related problems of probability to those of combinatorics and offered correct solution to the problem posed by Pacioli. The problem of points was essentially addressed in 1556. And also Galileo, probability and measurement of errors. After Cardano and Tartaglia came Galileo, who posited that errors of measurement are inevitable, symmetric, and clustered around a value. So that's a normal distribution. So, it all became mathematically precise later on, but essentially, Galileo essentially talked about errors of measurement, and this is what. So he revealed many of the characteristics of the normal probability distribution. So this marks the end of the phase of the earliest writings in probability after the prehistoric phase. So there is the prehistoric phase where data was collected, census was done, records were kept. Then came some writings by gamblers, and that brought the end of the second phase.
Was Galileo doing it from a gambling point of view too?
No,
No?
not that I know of. Okay, I don't think so. He was more interested in measurements.
In science.
Yeah, yeah, exactly. Huh. The beginnings of probability as a science. I need to fix my slides, Josh. This should come first. So all this was help given in Hong Kong. So, it was all done, and then I had to rejumble it and organize it. So the beginnings of probability as a science, these can be categorized in 5 stages, and it includes this period of stagnation. This period of stagnation is very important because it brought the Russians into the picture. And of course, they converted probability into a mathematical science. So let's keep that in mind. So there were also paradoxes in probability. And these paradoxes opened the door to the 4th stage. And within all this comes the evolution of statistics. So most of the effort was in probability and continues to be in probability. And statistics slowly enters within these phases. And of course, there is a lot of controversy about statistical methods, less so about probability. So we'll look into all these. Feel free to interrupt and ask questions. They help me clarify my own thinking. So development of probability as a science. Up until the middle of the 7th century, there were no general methods for solving probabilistic problems. Specific problems had been solved, and a substantial amount of knowledge was accumulated. So they were doing things piecemeal. I guess that's what the computer scientists are doing with machine learning, solving one problem at a time. The term probability itself nor its disposition as a number was not a part of the lexicon when solving such problems. In the mid-17th century, something interesting is happening. And to some extent, it's becoming clear that the first book on probability was written technically by a lawyer. And I'm getting to that point. In the mid-17th century, there were mathematicians like Pascal, Fermat, and Huygens. They became involved in developing probability even without mentioning this term. These individuals were familiar with the addition and the multiplication rules because Cardano had his book by then. They were familiar with the notion of independence and put into practice the notion of expectation using combinatorics. They developed new methods for solving problems, determined the realm of problems which this new science is applicable, and in so doing were on the verge of transforming probability into a bona fide science. This is what the historians say. They say probability is a part of science. If you look at some more recent literature, they would question mathematics and probability as a part of science. And that's a different matter. So comes the famous Chevalier de Maire, who was a philosopher and a man of letters. He participated in the solution to many mathematical problems of his day. With Pascal and Fermat, he was already famous. He had authored a book called Ars Cognitandi, The Art of Thinking, as a part of the Port-Royal logic. And there were two individuals, Arnold and Nicole, who were priests at the Port-Royal monastery. So what Chevalier de Maire did is he wrote to Pascal about the division of stakes and Pacoli's solution to it. The division of stakes was the driving problem. Two people are gambling. They agree on a certain set of rules. One of them has to leave in the middle. Somebody else takes over the game. How much should the person who takes over pay, and how much the person who leaves should be paid?
Did that happen a lot? It seems like a strange problem.
Well, it still happens. Two people are playing cards, and one of them says, I have to leave now. How do we break up the... So that is the problem of points. That is the founding document. This triggered a correspondence between Pascal and Fermat, and thus originated a founding document on mathematical probability. So it started there. Were these people gamblers? The answer is no. They were themselves not gamblers. Cardano was a gambler. He figured out empirically all the rules that we know of. We call them as Kolmogorov axioms. Kolmogorov was very familiar with those rules. I'll talk a little bit more about Kolmogorov as we move towards the end of this presentation. But the founding document was by Pascal and Fermat. Even though many mathematicians of that period devoted much attention to the solution of games of chance, actual gambling was condemned. Most of them were Catholics, I suspect. And gambling was not something that was, authorized by the church. Things may have changed. Thus, the myth that Chevalier de Maire was a fervent gambler cannot be true. Rather, he was a man of letters who used probability only as a useless curiosity. I think some scientists still think of it as a useless curiosity. I don't think so. I think it's becoming very powerful. Of course, Cardano used this. Used these ideas to gamble, but he did not quite arrive upon the notion of probability as a number. That was still not in the writings. This is an important individual, Huygens. Christian Huygens was a Dutchman from Holland. He visited Paris to receive a doctorate in law. He was impressed with the problems of gambling of Pascal and Fermat and undertook further work on it. He was told of the solutions, but not of the methods. These people were very secretive, just like how it is now, you know. You don't share your paper with anybody because you're afraid they'll write a paper on their own. Much of this was published. Newton was notorious for that. Much of these were published posthumously because both Pascal and Fermat posed problems to each other, but hid their methods. The correspondence between them was only published in 1679. More on Christian Huygens returned to Holland and began work on solving the problems posed by Pascal and Fermat. Huygens' solutions, independent but identical to those of Pascal and Fermat, were published in his book in Latin called About Dice Games. This book appeared in 1657, wherein Huygens says, "We are dealing not only with games, but rather with the foundation of a new theory, both deep and interesting." His reasons for writing this book was an absence of methods used by Pascal and Fermat. Thus, this book, written by a lawyer, is viewed as the first published treatise on mathematical probability. So I think it was a lawyer who essentially put the first document on probability.
Quick question.
Yeah.
What was Pascal and Fermat's answer to that? Their closely guarded secrets are now reinterpreted, or rather, their methods are now in print.
Oh, yeah.
What do they say?
Well, all that things was published posthumously. So everything was opened after they died.
How about his students and followers? What they say?
Probably. There's also another famous story about Bernoulli, who comes much later in Newton, and how they were competing with each other to solve problems. And there's a famous Latin quote. I forget exactly how it is, but just yesterday I was reading something on von Neumann, and they used that similar quote in the context of von Neumann. The quote has something to do with I can sense the lion by the paw of the lion. So it's a Latin, very famous. Okay. Huygens' book can be used as the first one on the introduction of probability theory until Bernoulli's famous Ars Conjecturandi, which is an imitation of Ars Cognitari. So this should be changed.
Wow,
Mistake.
no.
Two mistakes. Huygens' terminology was commercial, and his book was the first to introduce and to apply the notion of expectation in commercial and industrial problems.
Can you give an example of how they used it commercially for commerce? I mean, did they ask questions about?
Insurance is a very good example.
Oh.
Premiums.
Okay.
When the ships were going, they had to buy insurance. You know.
But not in terms of trying to decide how successful some venture might be, or
No, I think that hadn't. Not that I know.
okay.
That's happening now.
Yeah.
Okay. Now let's talk about data science. So that's the hot topic. Wendy works in it. A lot of people work in it. There are a lot of talks, a lot of newspaper articles. Data science. I don't know if it should be called science. Data is data. I'll tell you why it shouldn't be called science. Because science means real science, physics, chemistry, those kind of things, reproducibility, all kinds of issues come up, but they call it data science. But here is the beginning of data science in about 1662. At about the same time as Huygens' book, John Grant, an Englishman, published a tiny book developed to the problems of vital statistics. This grant is very well known among statisticians. Once when I gave a talk on some other topic, David Cox was there and he was very pleased to see John Grant. Most people had, at least I was in a department and a culture where all that mattered was what theorems can you prove, irrespective of how silly the theorems are. So when I mentioned John Grant, it came as a surprise to many. Huygens was asked to comment on this landmark book, which he did favorably. Indeed, in 1669, using Grant's work, Huygens constructed a mortality curve and initiated the application of probability to demographic and to annuities, to answer your question. In 1690, William Petty published his thesis on political arithmetic, which was about the method of reasoning on matters of government by numbers. That's government statistics. So this book was written by, it was called Political Arithmetic. It was written by William Petty, and there is an interesting background to this. Work on actuarial mathematics and the worth of annuities was due to De Witts in 1671, followed by that of Edmund Halley, who published the first mortality table based on data from Bross law. But here's something interesting. In 1791 and 1799, a Scottish gentleman by the name of John Sinclair published 21 volumes of his statistical account of Scotland to replace Petty's political arithmetic, which did not seem to have gained much traction. So the word political arithmetic was not exciting. And so he wrote this book and called it Statistical Account of Scotland. Question is, why did he use the word statistical? It had never appeared till then. The word statistics had never appeared, at least not that I can trace. Up until 1790, the word statistics was used in Germany to describe the political strength, happiness, and the improvement of a country as a measure of its well-being. So the word statistics was used in Germany to describe all this. Statistics was at that time an artificial word with no evidential meaning that is now used for anything having to do with data. Sinclair introduced this taxonomy to garner attention over Petty's term political arithmetic. I got this from a gentleman who's no more alive, who was German and who had studied a lot, was a statistician, probabilist, mathematician, studied a lot of this, and he pulled out all these things. And I've not seen it written in history books, but it may be. But this is where I got it from. So, to summarize, Huygens, a lawyer, recognized the role of probability as a science, wrote the first book on it, applied the notion of expectation to commerce and industry, and used probability for assessing issues in demography and insurance. And the word statistics was used by Sinclair in the context of, political arithmetic, in the context of collecting data and all that. The word statistics, it seems, was introduced by him.
No, sir, did the term political arithmetic refer to official statistics? I mean, what we would think of as official
Correct.
statistics? Okay.
It was called political arithmetic. The word statistics, it seems, according to, I forget the gentleman's name, he passed away, but I have his original paper with me somewhere. Because we were at the same conference. I was talking on something technical. He was giving an after-dinner talk, and he spoke about these things, and I was very impressed. So I looked at his article, and it turns out that he was a very strong mathematician. But at the same time, he dwelt into history and pulled out all these things. And being German, he probably understood the use of the word statistics in Germany much better than somebody like
Well, I think I read somewhere that it does have a German origin.
That's basically
Yeah.
his claim.
Yeah.
And you may have said it independently. So now comes the beginning of the science. So there are Bernoullis, and there's too many of them. Bernoulli, cousin Bernoulli 1, Jacques Bernoulli, Joseph Bernoulli, so on. But Jacob Bernoulli is the key person. He's also called James and Jacques. He introduced the probability based on the Latin word probabilitas and was inspired by Huygens' book. So the lawyer wrote a book. Jacob Bernoulli was, of course, a famous mathematician in those days. He and his brother were famous. And he introduced the word probability based on the Latin probabilitas. It was Bernoulli's works and book, Ars Conjectandi, which established mathematical probability. So all probabilists go to Bernoulli as the source of their inspiration. So how did all this come about? The word probability is based on the term probabilitas, which was to represent a moral system of the Catholic Church. Probabilitas was formally introduced in 1577 by the Spanish Dominican Bartolomeo de Medina and was mainly practiced by Jesuit priests as a system of moral logic. Bernoulli's aim in Ars Conjectandi was to introduce a new branch of science that he called stochastics, or the science of prediction. So the applied probability people don't use, that community uses the word stochastics rather than statistics and probability. The combination of probability and statistics, they call it stochastics, and they have journals, they have meetings, they have a whole culture devoted to it. So how did Bernoulli start viewing all these things? To Bernoulli, a relevant feature of stochastics was an event's readiness to occur, and probability, the degree of certainty of its occurrence. So probability was the willingness to occur, and stochastics was the willingness to occur, and probability, a degree of certainty. Thus, to Bernoulli, stochastics was the art of measuring probability as exactly as is possible. However, he acknowledged that determination of the true value of probability is impossible and labeled as mad any attempt to doing so. What he was basically saying is there's no such a thing as true probability. This difficulty motivated Bernoulli to develop his law of large numbers as an empirical method to determine lower and upper limit for an unknown probability. So law of large numbers came about because Bernoulli recognized that there was no such a thing as probability, but you can come close to it, to whatever it is. The definition of probability was devoid of mathematical content, but the laws, the law of large numbers was not. So here's a graphic. This is my contribution to this historical development. We start with Cardano, the gambler. We forget the prehistoric period. We come to Chevalier de Mere, the lawyer, who came to Paris to study law, looked at Pacioli's, Tartaglia's books, and was intrigued by their problem and their solution, wrote to Pascal and Fermat, who started solving those problems. And this culminated in Huygens. And then you have John Grant and Edmund Halley, both Englishmen, collecting data. The English are very famous for collecting data. Why we have a lot of statisticians in India is when the English went to India, they started collecting a lot of data on rainfall, cotton, and all, purely business. So these people started counting and adding, and then everything evolved. So why statistics is very successful in India is due to this particular historical origin. Okay. Now the Indians have moved away from statistics. They've gone into machine learning because now the economics comes. Okay, and then we have Jacob Bernoulli. So I call them the princes of probability. So Jacob Bernoulli, in his book Ars Conjectandi, proved the first limit theorem. He raised the status of probability to a mathematical science. His work was published posthumously. Bayes has still to arrive because they say the only good Bayesian is a dead Bayesian. So I think Bernoulli was in the same boat. His book was published posthumously by his nephew, Nicholas I Bernoulli. So there is also Nicholas II coming, who wanted to apply probability to jurisprudence like witness reliability. So there is a lot of legal, there is a nice field which I wish people would get into, that includes people like myself, and that's in the context of law. My colleague Joe Gastworth has been doing it. There are some other well-known people in the US who are doing it, but the masses need to get involved in this area. But Nicholas Bernoulli was interested in that, but there were others who also came into the picture, like Laplace and others also wanted to apply the laws of uncertainty in the context of law. So what Jacob, I use the word Jacob rather than Bernoulli because there are too many Bernoullis. So the first name is Jacob, interpreted propositions in Huygens' book, showed inapplicability of the addition law to disjoint events, gave the binomial formula and used Leibniz combinatorics for solving probability problems. He proved the weak law of large numbers as a way to bound a true probability, interpreted probability as the degree of uncertainty of an event's occurrence, but he was a metaphysical determinist. That is, his view was if we know everything about the flip of the coin, all the physics, then we can exactly predict his outcome. Later on, quantum theory showed that even God could not predict. That's what they say. Thus, to Bernoulli, probability or chance, the terms used interchangeably depends on our knowledge. However, since all knowledge is not possible, we assume a statistical regularity in a large number of trials and conclude that for tossing of coins, the deviation of m over n from p as n goes to infinity is small with a large probability. So with the law of large numbers, people say that you can define probability through a large law of large number. That is not true, because when you write the law of large numbers on the left-hand side, you have the word probability. So probability pre-exists before you can make the case for it. So Bernoulli also touched on the philosophical problems, and Bernoulli also felt that it should be applied outside the games of chance. Besides Bernoulli, there were others who worked on probability during the beginning of the 18th century. Here is a famous name, Pierre De Montmartre. He was supposed to adjudicate between who invented calculus. Was it Newton or Leibniz? Leibniz chose him, but he ended up supporting Newton. Okay, and I'm going to go a little bit faster. It was in a letter to Montmartre that Nicholas Bernoulli posed the St. Petersburg paradox, and Nicholas won, and Montmartre's interests were in the application of probability to human behavior. So comes De Moivre's. Abraham De Moivre's principal work in probability was written in the book called The Doctrine of Chances. Here, without addressing what the meaning of probability is, De Moivre discussed topics connected with Bernoulli's theorem and the problem of duration of the play, first proposed by Huygens, and apparently De Moivre discovered the Gaussian law. And Laplace extended De Moivre's work for any p, And therefore, we call the second limit theorem as the De Montmartre-Laplace limit theorem. So we have to talk about Bayes. It seems that Bayes was tutored by De Montmartre. De Montmartre was English, despite the fact that his name is French. He was a French Huguenot or something like that, but he was basically English. So Thomas Bayes was tutored, published his famous essay posthumously entitled Essay Toward Solving a Problem in the Doctrine of Chances. So Laplace and Bayes went to the philosophical question of induction. And their biggest contribution was not Bayes' theorem, nor Bayes' law, or at least one of the great contributions was the introduction of probabilistic induction in the context of philosophy of science. So I just wanted to mail these. So I would skip this slide, but it's there. And Daniel Bernoulli introduced the idea of probability curves, applied differential calculus to the probability theory, simplified many of the cumbersome issues, and solved the St. Petersburg paradox and introduced the notion of utility for the first time. And game theory with von Neumann and Morgenstern leaned upon this particular original idea later on. So that's not a part of today's talk, but I just want to allude to you that this is what happened. Okay, then what happened is, historically, there was the French Revolution. They wanted to use probability in social sciences, in human behavior and all, and the mathematicians just didn't like it. They tell that this was all beyond the scope of mathematical probability. But after Bernoulli came Laplace, and these are his contributions. But just to make a quick story short, Laplace talked about probability being subjective. He said probability cannot be objective, it has to be subjective. That went far. That idea went far. Okay, stage 2 ends with Gauss, who derived the Norman law for the distribution of errors. This was also done by an American mathematician, and then Poisson, who was trained as an engineer but did a lot of mathematical work, subscribed to the subjectivist view and felt that probability can be applied all over. So here's Poisson's formula. I won't go through that because that essentially is something everyone is familiar with. Now comes the stagnation. The stagnation was very important because it brought in a completely new element into this Eurocentric picture of Austrians, Swiss, Germans, and English. It brought the Russians into the picture. And in some respects, they made a dramatic change, not in terms of ideas, but more in terms of the mathematics. Many felt that its application to social problems was a compromise in the exactness and precision of the mathematical sciences. So they'd be unhappy with the Census Bureau and all these places, but this is how it was. There was much controversy about the subject. There was much criticism also of Pascal, Bernoulli, Laplace, and Poisson for their subjectivist inklings via metaphysical determinism. So the Bayesians are criticized, but these people were also criticized. So what happens now? What happens now is the Russian school enters the picture. And who are the characters that are involved? That's very interesting historically because we never read about them or hear about them. Well, we do, but not in regular books. The origin of the Russian school in probability were Ostrogradsky and Bunyakowski.
Right, I haven't heard of them.
No, you haven't. And when I taught this course about, when I first lectured on these kind of issues about 10 years ago, there were two Russians, because the Russians had started coming to the country. You know, they knew who these people were. They said, oh yes, these are known to the Russians. Ostrogradsky was influenced by Laplace, was a proponent of the principle of insufficient reason, and applied the theory of probability to moral problems. Now, these were also distinguished mathematicians. He too subscribed that probability is a measure of our ignorance and is therefore subjective. Bunyakowski wrote the first book in Russian in probability and introduced the needed terminology. He too was a determinist in the spirit of Laplace. Well, we've all heard of Chebyshev. Chebyshev polynomials, queuing theory, Chebyshev equations, Markov chains. He was influenced by Ostrogradsky, and Bunyakowski is now being credited as the creator of the now famous school of probability. The students are Markov, Voronoi, Lyapunov, Steklov, Prushta. You must have heard of all these names.
Yeah, not the last one.
Which one?
Steps.
Oh, Steklov. No, the Steklov Institute in
Oh.
Russia is named after him. Voronoi, operations research people know
Oh,
him.
yeah.
Lyapunov, control theory people.
The Voronoi tessellations.
Yeah,
Yeah.
all those. So those were his students. They broke the phase of stagnation and impasse in probability as a mathematical science. Chebyshev defined the essential subject matter of probability as the mathematical science of constructing probabilities on an event based on probabilities of simpler events. That's what probabilists basically do. And he did not discuss how the initial probabilities of the simpler events are obtained. But if you have the initial probabilities, how do you combine them and build up? That he did. Chebyshev introduced mathematical rigor in the theorems and obtained exact estimates of inequalities of derivations from limiting laws which arise when the number of trials is large but finite. They were materialists. They were all interested in the natural sciences, so they approached the subject from the point of view of physics, chemistry, mechanics, and things like that. They were guided by the opinion that only those investigations initiated by applications are of value, and only theories which arise from consideration of particular cases are useful. Very pragmatic.
That sort of has a data science flavor, doesn't it?
That does. The materialist philosophy is founded on the belief that nothing exists but matter and its manifestations, no abstraction. But that created problems. So we have Markov, Lyapunov, and probability. Markov was Chebyshev's closest principal and his most colorful spokesperson, who transformed probability with clarity and rigor to a perfect field in mathematics. Markov's son, was the head of the Department of Linguistics at Moscow State University. Markov's son, this Markov's son. When he died, his son died, Kolmogorov moved from statistics to linguistics because Kolmogorov became very much interested in linguistics, and that should resonate with what you're doing with your language processing, because I felt that language is very important to problem. Because you have to express yourself very clearly, otherwise you'll do the wrong calculation. But anyway, let me just finish. Of course, everyone knows that there are all limit theorems named after Markov, and he introduced the Markov chain.
So Markov chains are in natural language.
They are,
Yeah.
but it started with him trying to understand this poem, Eugene Onegin.
Oh, really?
He wanted to understand the literature was very important. So he wanted to understand the vowels and the verbs and the thing. And Markov chains were introduced by him in an effort to understand this. He improvised on the proofs of Markov's theorem, okay, so all this, happened in this particular context. We shouldn't forget, people always say that, what about physics, probability in physics? Well, I don't think the physicists contributed to probability from the, there may have been individual physicists, but Einstein essentially applied. Robert Brown was the English botanist who discovered suspension of particles in the fluid. Einstein explained those using Gaussian processes. So that is Einstein's contribution, and it was very significant because he was the first to bring this into, bring probability into physics. So we should mention this.
Was that Brownian motion?
That is Brownian motion.
Okay.
The Brownian motion was analyzed by Einstein, and I think he got his first Nobel Prize. I'm not sure about that. He got 2 Nobel Prizes, so I'm not sure. Yeah, I think the first one was this, and the second one was not due to relativity, but the radiation. Yeah.
Einstein got photoelectric.
On the photoelectric. That is the second.
He got 1 prize.
He just got 1? I see. Okay. But at least he was famous by then.
Well, this is a very famous result, for sure.
Yeah. So when he got, I think this came before the photoelectric effect.
Same year.
Okay. Yeah. Okay. Boltzmann and Gibbs. Okay. I'm just going to go a little bit fast on this because these are just completeness that there were physicists who played a role in this. Okay, so quantum theory came about, and right now, quantum theory is very probabilistic. Very probabilistic. Okay, let me just skip this and get to paradoxes. Great inroads were made. However, the mathematicians were repeatedly pointing out the need for a precise meaning of probability. Nobody had a clear meaning what it means, okay? And that continued for a long, long time. Indeed, okay, I'm just giving examples of the lack of a proper definition. Borel and Poincare, both prominent French mathematicians, whose view was probability is a reflection of ignorance. Both wrote 2 highly influential books and called for the rigorous definition of the meaning of probability. Such calls can be seen as paving the path towards on the axiomatic development of probability and the subjective probability. So up until then, the meaning of probability was not clear. So what about this axiomatic development? I'm just going to clarify one particular conception that most people have. They think that Kolmogorov created the axiomatic development of probability. But there is a precedence to what Kolmogorov did. And that is by somebody called Lobachevsky. I'm sorry, somebody called Bernstein, who essentially said, Lobachevsky suggested the possibility of constructing geometry based on axioms, which are different from those of Euclid, whereas Hilbert and these people investigated the possibility for geometry, and they did this for arithmetic. With probability, Pascal's classical definition, equiprobable means equal probability, was a tautology, so they were not very happy with it. subjective interpretation of probability had some trouble from the economists because of the linear utility and the state dependence on money. So the axiomatic pressure was becoming more and more pressing. So this is the man I wanted to mention, Bernstein. There's a very interesting article written by, I believe Chebyshev on Bernstein. A lot of, so published a paper hinting the axiomatization of probability. Bernstein's axiomatization was based on the notion of qualitative comparison of events. And this is also very important. The first point is important. The second point is also important. His ideas were further developed by Gilimenko and more recently by Koopman. Bernstein's notion was probability was materious and was for application to the natural sciences. Well, von Mises was a critic of both the subjective view and the equiprobable view. And of course, he proposed the frequency view. Approaches alternative von Mises were due to Keynes, Jeffreys, who viewed probability as a degree of likelihood, wherein every proposition has a certain definite probability. It says that Keynes recanted this position later on. Simultaneous with the attempts to lay the foundation for probability were rapid new developments in the mathematical sciences, vis-a-vis the works of Khinchin, Borel, Cantelli, Hartley, Littlewood, and House. These trends enabled Kolmogorov to construct an axiomatization of probability and to lay the foundation for a decisive stage in its development. It turns out that Kolmogorov was not interested in uncertainty and probability originally. He was interested in properties of a system of sets with certain restrictions, probability being a restriction. So Kolmogorov's contributions was motivated by mathematics rather than by the treatment of uncertainty. Later on, of course, he may have seen the virtue of what he was doing. But the weak law and the strong law enabled Kolmogorov to make a connection between probability and measure theory. And that is the point of his 1933 famous book. So Kolmogorov's aim was not to clarify the meaning of probability, but to establish a branch of mathematics in the same way as algebra and geometry. So to Kolmogorov, the concept of a theory of probability is a system of sets which satisfies such certain conditions. So he said, let us talk about probability devoid of any context, and just let's talk about the probability, the properties of a system of sets which have these issues. Not all applied scenarios satisfy Kolmogorov's axioms. Consequently, there are alternatives which are given here. And what I want to do now, probably stop, but just say that all this opened the door to the subjective interpretation of probability, which was De Finetti and Savage. And Savage was influenced by von Neumann and Morgenstern. Von Neumann and Morgenstern were influenced by Daniel Bernoulli's notion of utility. And the rest is a talk in its own right, because there is a lot involved about how subjective probability can be motivated and what are its weaknesses and so on. So perhaps it's a good time for me to stop. Is this time good?
Yes.
So it's about an hour.
Okay. Yeah, this is a good time. So
And we can take questions.
Yeah.
Thank you.
I have one question. So subjective probability, though it seems like that was already thought of, but maybe not in the same way.
It was hinted by Borel. It was also hinted by, it was hinted mostly by Borel, and before that, I believe by Laplace. So it was hinted. It's the most defensible position that I can tell right now. It's defensible in the sense you cannot logically challenge it. You simply say it's my opinion.
Okay.
So you
okay,
don't
that's
challenge
what
my
I-
opinion. At least I think so.
All right,
Hi.
yeah, Mike.
I just want to point out that Vermont was also a lawyer for the administrative judge.
I think you're right.
Yeah.
Yeah. In those days, they educated broadly. They were all educated broadly. You're right. Foma was a lawyer too. That's true.
I have another question.
Sure.
I'm probably not asking it right, but I've encountered sort of controversies in the past.
Yeah.
Connecting probability and statistics
Yes.
that sort of in my mind, I kind of lump them together, but some people say, no, they're kind of completely separate.
Yes.
And
Yes.
so could you
Yes.
say a little bit about
I
that?
can. I went to a meeting in France to review a department where I'm telling you I have a friend.
Okay, good.
And there were 5 of us, 2 very famous statisticians. And one of them stood up and said, statistics is not mathematics and statistics is not probability. He said it very forcefully. I don't know if the others challenged him or what. So I've heard that point. Well, statisticians have a different philosophy. They have a philosophical background. So I would say that statisticians use probability. We all do. It's part of the toolkit. But the two can be separated. People in probability do different things. If you open a book in probability, you don't see the word data or likelihood or anything.
Oh,
So,
really?
oh no. You'll
Not
see the
like-
word. You'll see the word likelihood, but it is used exchangeably with probability. Yeah, but in statistics books, likelihood means something.
Any more questions? I'm just going to check online to see if we have any.
They're gone.
No, they're still hanging in there. Okay, any questions online? No. Okay. All right.
Yeah.
Well, oh yeah, one question. Go ahead.
This is Jim Phillips up in this. Very nice presentation.
Oh, thanks, Jim.
Great to hear you. What does your research say about the first use of the word data?
That's a good
Or
question.
the
Wow.
word-
Sorry.
He said, do you have any information on the first use of the word data?
No, I don't.
That's a good question.
Sorry, Jim.
Okay.
I
Also,
don't know. It probably some Englishmen use the word. That's all I can say.
That sounds like a good homework problem.
But the word statistics is German. I don't know if I was aware of that 2 years ago.
Okay, I have a second question, but Hari has a.
Finish here.
My second question doesn't have anything to do with probability, but it's an update in terms of a last millennium. A person who I really respect made a comment that data is just background information, and I would like to know if if there's an update on that millennium.
Who is the person who said that? I agree with him.
You.
He said somebody referred to data as background information.
So I agree with myself.
That's good.
Yeah. No, yeah, because you see, you use data to form an opinion and you update your opinion based on more data. So I think it makes sense to look at it from that perspective.
Very good. I really enjoyed your talk. Thank you.
Thank you very much.
No, sir, there is one more question. This is Hari, also from NEST.
Hi, Hari.
So regarding subjective probability,
Yeah.
my understanding is that it's wonderful for personal opinion formation or decision making.
Yes.
Why would one person's probability be of use to another person?
Well, I kind of agree with I'm sorry. I've heard the comment that subjective probability is for personal decision making, and the frequentist probability is open, is a common thing. But you can use frequencies to update your personal probabilities. So, it all boils down to personal probability, doesn't it?
Yes, it does.
Yeah, that's.
Follow-up question is, when experts provide testimony in the courtroom in criminal trials, these days they are starting to use probabilities and likelihood ratios or base factors.
Yes.
It makes sense to me that if jurors are well trained in probabilistic methods, they can and must use, if you follow Savage's axioms, must use their own probabilities to make up their minds. Why would an expert's probability be of use to somebody else?
Well, I think I'm not sure if I can answer your question satisfactorily, but my feeling is that the role of the expert is to convince your attorney about what you're thinking, and it's up to the attorney to translate that to the layperson and relate it to the layperson.
Sorry.
So.
Okay, thank you. I would like to, I hope there's opportunity for further discussion on topics related to use of probability in the courtroom, but that's
Sure.
for.
Okay, you're at NIST, right?
Yeah.
So I'm local. You're local.
Okay, I'll contact.
Yeah, keep in touch.
Yeah.
I've returned from Hong Kong now. I'm no more going back.
So he's definitely local now.
I'm definitely local.
All right.
Thank you.
All right, now we have the microphone. Okay. All right, well, let's thank those again.
Thank you. Thanks for coming.
Yes, thank you, everybody.
I'm just going to make a trip to the men's room.
Yeah.
Thank you.
Oh, you're welcome. Thanks for coming. And you got the fancy chair too. All right, thanks everybody out there. We're shutting down.
I thought to ask him if Markov discovered anything.
Thank you.
I.e., was it objectively?